Hi, future doctors. Welcome to the next class. In this class, we will discuss about electric field intensity due to non-conducting sphere. So, if this is a non-conducting sphere of radius capital R, this is a non-conducting sphere of radius capital R. So, on this, we have given some amount of charge. Non-conducting sphere means if you have given charge, it will be there only. It will not move to surface. The charge is going to be occupying entire volume. Now, how much charge is going to be present within this sphere? So that is only rho is equal to charge per unit volume. So then, how much charge is available within this volume means rho into V. So what is the volume of this sphere formula? 4/3 pi r cube. This is the charge available within this entire volume. Now again, if you want to find outside on the sphere, within the sphere. So first we will see outside. If you are taking it is outside anywhere, this point P is outside. Again you have to close the charge enclosed by the surface. According to Gauss law, we are going to close the surface. What is the distance of this point means small r. Now, according to Gauss law, we will write like this. Phi is equal to same like previous conducting sphere or spherical shell. E bar dot ds bar is equal to q by epsilon naught. Now, same like this small surface area ds, it will be direction will be n cap. For positive charge, electric field intensity also will be away. So both E bar and n cap in same direction. So E ds cos 0. Because previously we discussed this, directly I am writing integral ds. Yes, q by epsilon naught. So E into what is this? Yes, surface area of this Gaussian surface. What is the Gaussian surface area? 4 pi r square, surface area of this one. So this is 4 pi r square. What is capital Q now from here? So capital Q is nothing but rho into 4/3 pi r cube divided by epsilon. So 4 pi will be cancelled. Then electric field intensity due to non-conducting sphere outside is rho by 3 epsilon naught into r cube by r square. So, because of non-conducting sphere, outside how much electric field intensity is available means this much electric field intensity is available. So, rho by 3 epsilon naught r cube by r square. Now, on the shell if you are taking, on the shell whenever you are taking, again same like previous conducting sphere. So, on the shell if you are taking the point, then small r and capital R will be same. So, E outside, how much we got? Rho by 3 epsilon naught, capital R by capital R cube by small r square. Correct? Capital R cube by small r square. Check once previously. R cube by r square. Now, see here small r equal to capital R. Whenever small r equal to capital R, E outside is equal to rho by 3 epsilon naught r cube by r square we can write. Correct? Small r. Correct? In place of small r, capital R we got. What will be cancelled? R square, R will be cancelled. So, rho capital R by 3 epsilon naught. This is on the surface. Isn't it? So, outside rho by 3 epsilon r r cube by r square. On the shell rho r by 3 epsilon. Now within the shell or within the non-conducting sphere. Within the non-conducting sphere means within this how much charge is available. See here. So how much charge is available on radius capital R? Same charge is not available on the sphere which is at a distance small r. So charge is going to be changed. So how much charge is available within the smaller sphere? So for that very simple. So Q charge is available rho into 4/3 pi r cube in the bigger sphere. Now how much charge is available on the smaller sphere means Q dash rho into 4/3 pi small r cube. Correct? So within this capital R cube, this much charge is available means within this small r, this much charge is going to be available. Now again, if you wrote our formula, so E integral ds, I'm not writing remaining all, directly we are writing how much charge is available now? Q dash by epsilon. What is surface area of the smaller sphere means again 4 pi small r square. Now what is Q dash? Rho into 4/3 pi r cube by epsilon naught. Now if you cancel 4 pi, 4 pi. If you cancel 4 pi, 4 pi, again you are going to get 1 r square, 1 r is going to be cancelled. So E within the sphere is equal to rho by 3 epsilon naught. What will be remaining here? Small r. So without this derivation, how to remember this easily means E outside already we wrote. What is E outside? Rho by 3 epsilon naught r cube by r square. So surface we wrote. What is on the surface? Rho by 3 epsilon naught into capital R. So E within the sphere, just rho by 3 epsilon naught. In place of this capital R, you have to write small r. Correct? Now see how it is going to be varying. E outside is inversely proportional to r square, but E inside is directly proportional to r. If r increases, E value will increase. From center to surface, it is going to become increasing. What is it? Its value at center. R value is going to be 0. Therefore, it is increasing at center, it is going to be 0. It is increasing from 0 to rho r by 3 epsilon naught if it is coming to surface. Correct? If it is directly proportional, here it is inversely proportional. Therefore, how you will get graph nature for non-conducting sphere. Already we have drawn for conducting sphere. So graph nature for this will be from center to surface. Its value is going to be electric field intensity value is going to be increases. Later it is going to decrease. Therefore, so surface if we are going to take, its value is going to increase if R is equal to capital R. Later, it is going to decrease. This is outside is inversely proportional to R square. So inside is directly proportional to R. So for conducting sphere, how this graph came? So for conducting sphere, how this graph came means like this it came. So from center to surface it is going to become 0. E outside is inversely proportional to R square. It is going to become 0. Correct? E inside is 0. On surface its value is going to increase. Later its value is going to decrease. Here also directly proportional, therefore it is going to increase, later it is going to decrease. This portion is same for both, but this is going to be different. What is this maximum value here? We got rho r by 3 epsilon naught. Very, very important graph in final exam point out. So again, questions on this according to this equation they're going to ask. Which equation? This equation. So inside, outside, how it is going to be changing. So depending on these equations, they're going to ask. Remembering these equations are very, very important and easy also. Logically, if you go, it is going to become easy. And this one also sometimes you are going to get. The total charge on sphere is different. Total charge on how much portion you are going to be taken is going to be different depending on the distance. Isn't it? Therefore, try to remember these three equations. Definitely, you can solve problems very easily.